thank you for being here today. Yeah, as I said, I would like to discuss the 3 R's of sustainability, and I would really like to highlight a little bit the reuse R, because I think this is something which is not so common up to now, and I think that's by that very interesting for everybody. So let's jump into the presentation. First, one slide, who we are. EDAG is an automotive engineering company. We are located more or less everywhere where cars are produced. We have our headquarters in Germany. Most of our 8,000 employees are in Germany, but we're also in the US, China, India, Brazil, Mexico, Sweden, Spain, wherever. Our job is quite simple. We do everything you need to do to design a vehicle. So if you just have an idea how you would like to have your own vehicle, we can give you the vehicle. We can do everything from design to engineering, software, electronics, up until production planning and prototyping. But now, sustainability is a very influencing factor to us, and it's influencing all what we are doing. So we introduced some ideas, some skills to our engineers, which is, as an example, life cycle assessment of every component, which is green logistics, for an example, and the use of new materials, which is really facing a growing demand. Why are we doing that? I'm just taking market and just taking a look at what our customers is. One of these customers is Mercedes-Benz, is saying. So they want to be carbon neutral by 2039. And they want to measure the carbon neutrality along the entire value chain, which means everybody who's delivering a material, a component, a product, a software, is part of this carbon neutrality, and everybody must be neutral. And they say one thing very clearly, they say, we put this into our contractual terms, and if you do not become carbon neutral, you won't deliver any parts to us. So that's a very strong sentence. Yeah? So it's really a change for everybody. Another big OEM is BMW. They want to reduce their emissions by 40% by 2030, and they also want to be carbon neutral, but maybe a few years later than Mercedes-Benz. But they say something different. They say they want to have a circular economy approach, which means they want to have a vehicle which is built by them, but they also want to have an idea and process for dismantling it and collecting back the materials to have a real circular economy approach. So these are sentences by our OEMs, by the large companies of the automotive industry, and this is influencing what all the suppliers and also material suppliers have to do. And it's clear they want to achieve this goal of carbon neutrality that we all have in common. Taking a look at EDAG as an engineering company, we are working more or less in the areas of conception and the development. The carbon footprint today is created more or less in the production phase. The influence of the use phase has decreased since today we are talking about electric vehicles, and they can be driven with green energy. So the production today is the major point where the carbon footprint is created. But something important to see is that the influence taken on this footprint cannot be taken while you are producing. You cannot change too much in your system, in the construction, and so on. This has to happen before that. So we as EDAG, as engineers and designers, we are in a very strong and important position to lower the footprint. So our job is really to get down these emissions, and that's more or less our job. It's not only the job of the companies that are producing, it's also the job of the engineers, or maybe it's more the job of the engineers than the job of the producers. So our tools are quite known. Let's reduce the weight, let's reduce the emissions, let's recycle as much as possible, and also let's try to reuse some parts. And reuse for vehicles is quite difficult, let's say. So we have done reduction all over the time. Lightweight design is quite known. We have done so many lightweight design vehicles, approaches, and whatever. And this is still an important topic, but maybe this time it's not only about reducing the weight, it's more clearly about reducing emissions, which is not exactly the same. So I have some examples with me. So we have for the reduction of emissions, as I said, some years ago, we only cared about the weight because weight was important for fuel consumption, weight was important for performance of the vehicle. But now we take into account the carbon footprint. And this is a very simple graph. And it's quite complex too. So it's simple because it's only showing a few things. It shows the cost of material cost of a single part, and it shows the global warming potential, which is how many kilograms of carbon emissions are generated per kilogram or for this product. And the bubble size indicates the weight. And there are some things which are, let's say, independent. And these are, for me, these are load cases. I'm a mechanical engineer, and the load case, which is quite simple, is this one. We have a rod of 1 meter, and we are given a force of 1 ton. So 1 ton is pulling at this rod. The question is, which material can fulfill this load case best? It's clear all the materials can fulfill it. The question is, how large is the rod? What's the diameter of this rod? And this is indicated by the weight. But there are other factors. As I said, the costs are different and the global warming potential is different. And you can see this graph, and it's helping you to select which of these materials is best. Just concerning the weight, carbon fiber epoxy is perfect. It's the smallest bubble. But concerning the costs and the global warming potential, you see glass fiber composites or simple steel are also quite good for fulfilling this load case. And there are so many different other load cases. There's bending, there is crash absorption, there is eigenfrequency and whatever. And all of these load cases have different graphs. And these graphs can really help you to find out which material suits best to your load case. And if you're using this, this helps you to reduce your emissions. We are also talking about recycling. And recycling is really helping. As you can see from this graph, the red one is primary, which is more or less iron ore creating the steel, or for aluminum bauxite, or here for the plastics, it's crude oil. But the secondary is indicating what happens if you reuse or recycling the material which is already in the market. So for steel, you see this lowers the footprint by far. Same happens to aluminum, polyamide, and polypropylene are also given a good indication. And this is emissions per kilogram. So recycling is a very good way to reduce the emissions. The average value comes from what's standard today in the market. And you can see that today the emissions for aluminum are quite high still. If you cannot use the secondary aluminum, and also the steel can really face some more reduction. Please keep in mind this is per kilogram, and steel has a very high density. So we can really help to reduce the emissions by having secondary materials, so recycling materials, but also please keep in mind we cannot reduce this to zero. We are not jumping across the zero by you doing that. So what could be another option? Use of natural fibers, for an example, and bioplastics, because in theory, they can be produced with negative emissions, because the fibers themselves are consisting of carbon atoms and they are coming from the atmosphere. So we can reduce the carbon in the atmosphere, so we have a negative footprint. And one example here for us is our Reksha project. We defined seating structure and we did the simulation and the testing of this, and we could prove that it's possible to have structure components like a seating structure, and in this case, particular for children, so child seat, which is critical. And we can do this with bio-based components like biopolymers and flax fibers. Today, the carbon footprint is not negative because the production rates are so low. We are not very efficient in the production of that. And today we are not really using only green energy for the production. But in theory, we can reach negative emissions with these constructions. And why the child seat? Because parents, I'm also one, are willing to pay a bit more for sustainable things for the children. So we see this as a very good solution. But as I said, this was reduction, this was recycling. Both are possible, but this is still very expensive. It's expensive and sometimes generate material properties you need for the performance. So another idea is to reuse. And we had a very large European funded project, which is called Fiber Reuse. As the name says, it's about reuse of fibers. Our idea, beneath all different other ideas in this project, was to reuse parts as they are. Carbon fiber parts, because carbon fiber reinforced plastics have a very good fatigue strength. And in a vehicle, which is active for about 4,000 hours over the lifetime, we cannot really take use of this durability up to now. This is the case for wind power blades and planes, for example, but in the vehicle life, we cannot really take use of this very good fatigue strength. So our idea was to enlarge the lifespan of these important lightweight design components for more than one vehicle life. So that's why we said, let's create a vehicle structure that is important, being reused, and do this for a fleet sharing vehicle, which is a fleet-owned vehicle, because there we can get back our components. There we do not have a logistics problem because the car is sold to another one, and we never get back these components. The approach is quite simple. We defined a major part of the vehicle structure, which is in this case the battery housing. And then we can attach the back of the car, the front of the car, and the so-called greenhouse to it. And for the disassembly, it works quite backwards. It's very, very simple. So what did we need for that? So we needed detachable joining technologies. They're quite critical. So one thing is quite common, using bolts. Bolts can be attached and disassembled. It's no issue. In this case, we developed special sealing frame, which enables to use the bolts in the y direction. This makes it much easier for workshops to get back the battery housing. But what happens for adhesive joints? In some areas, we have to use an adhesive for sealing and for fixating. So here, in this area, this is between the crash absorber and our large profile, which is forming our reusable carbon structure. We had to use an adhesive. And we thought, why not just cut right through this adhesive? The adhesive has a thickness of 8 millimeters. It's quite large, and it's also there for damping. And we thought, why not just cut through this? This is a process which is done for windshields already. If you get a new windshield, then you're cutting this with a wire saw, and then you put in a new one. And we thought, why not doing this for structural components? And we had some experiments on that. What you see is a part of a BMW i3 up here. And I was doing this myself, so it was quite hard work, but it was possible to cut right through this adhesive. And as you see, the carbon fiber parts is not cut, it's only the adhesive that is cut, so we are not destroying it. After that, you have to remove the adhesive, which is quite simple, much simpler than I thought. And then you have the clean part. And then you can attach a new adhesive, and you can put this back into the next car. So the good news is that the cutting of an adhesive is a quite applicable technology. You just need an even surface, and you could also use a CNC wire saw instead of your own hands for the cutting. And we had some experiments about this too. So cutting of with a CNC wire saw was much easier, and they are quite accurate. So they have very low tolerances, and this is really helpful and automatizable. But what happens if you do not have an even surface? And most surfaces are not even. Then we had another idea. We had to destroy the adhesive while cutting. So we thought about how can we destroy the adhesive but not the part. And we thought about maybe we have a trigger which is activated at a certain temperature. And we found one. So we have those thermally expandable particles. They are expanding at a temperature of about 100 degrees. And they can expand up to 40 times their size. So they can destroy the adhesive around them, which could then give us the possibility to detach. And we had some experiments about this. It's working with structured adhesives like epoxies. It's working with semi-structured adhesives like polyurethane, and both work quite well. And here you can see the separation temperature. It's depending on the amount of these particles you put into the mixture. And we could have the point of detachment at about 110 to 120 degrees. And this is quite helpful because the carbon fiber part survives 120 degrees. The rest of the structure of the vehicle survives 120 degrees. And this is a temperature which is never seen in this area during use. So it's a perfect condition. And if you want to detach those parts for the not even surfaces, just put the structure into an oven, heat it for 120 degrees, and then you need very little effort just to detach those parts. So it's a quite applicable process. So this means we can now have a different product life cycle. A standard life cycle is virgin parts go to assembly, you have a use phase, you have a disassembly, and everything should go to recycling. But for our structure, we go with the major structure parts to the inspection. If everything is okay or remanufacturable, we go to remanufacturing step. And if this is made, so for us, the remanufacturing is removing the adhesive, and which is cleaning the surfaces. And then we can bring back our structure into the assembly for our next vehicle life. So our design is ready for that. And we did a life cycle assessment about this. And at first I have to admit, during production, we need more emissions because we have carbon fiber parts. Carbon fibers have high emissions. But then after first use phase, in this case, it's only 4 years because we say this is a car sharing vehicle, which is in service for 2.5 hours a day, which generates 180,000 kilometers, which means the car will be broken after 4 years. Here we can reuse the platform. And right in this point, for the reuse, when we do not have a new production of our platform, we are saving emissions. And you can continue the story for many more years. So we say up to 7 times is no problem. And this is really generating much less emissions. And you could, this is a calculation which is done by not using only green energy. So this is really indicating that our idea is not so wrong. And by the way, it is possible. We had also some calculations to have this system, this overall system, on an economic base in a good position. So it's generating profit by reusing because you're saving the money for reproduction. And we like this idea of reusing and long-term use of parts. So we generated the next project, which is called a COSA project. This is a little van, multi-purpose van. And here we had a similar approach, but we said, why only reusing one single structure? Let's reuse all the different structures. And by reusing it, why not maybe changing the job of these parts? So maybe we could change the shape of the car. This could become also a pickup. And so the exchange of parts, and here very important, in addition, a distinct lifespan for every part. So a plan for exchange or remanufacturing is included for all those parts and components. This is for us the next step, and we develop different other things which are quite helpful. A very good example is this crash absorber. A crash absorber is never really in use. That's good news, because we do not have so many accidents. So this crash absorber is perfect for being reused, because during the whole lifespan, a crash absorber is never facing the maximum load case. And that's why we say reuse those crash absorbers, make them in a lightweight design technology for saving the weight, for needing less energy, for giving more usable weight for the vehicle, and reuse those structures. So we are using, again, CFRP for those tubes, crash tubes, and they are in a modular system. After the first vehicle life, you can just get them back and bring them into the next vehicle. So that's a quite simple idea, and we're really optimistic that this is one thing that could really make the way into the market. Another thing is our rear axle. This is a new patented system because we are using here a leverage arm for having this leaf spring. And this leveraging arm means that the overall strain in the spring is reduced, and we could possibly also use carbon fibers in the leaf spring, which is also new. And the next benefit is, if you want to change the purpose of the vehicle, maybe you need another spring rate. Please consider, for every vehicle you are ordering today, for example, at VW, they have more than 20 different springs available just to adjust your suspension system to the vehicle you just ordered. So it's depending on the weight of the vehicle, it's depending on the functions of the vehicle, and so on. So here in this case, we can adjust our spring rate by just moving our leaf spring back and forward. And we could also move the adjustment of the leaf spring. So we have different options, and we can just adjust our spring to the purpose or the new purpose of the vehicle. So another very good point, and we do not have to change anything. Here also we did a life cycle assessment. In this case, we said we want to stay in service as long as possible, which in this case could mean about 10 years in a sharing vehicle. And here we did the comparison between reuse, a reusable platform, which is A, then B, a non-reusable, but still carbon-intensive platform, so carbon fiber-intensive platform, and a conventional platform. And you see that the conventional platform, the linear economy, lightweight design platform, they're quite similar. But the game changer is the reuse concept and exchange concept, which saves about 62% of the emissions. And this is really helpful as we think. And please keep in mind, we could also combine this with other recycling technologies. We could use recyclates more and more. And this together could really help to reduce the overall footprint of a vehicle. So we are quite convinced that reuse is a good idea, but as I said, there are always some logistics problem and so on. That's why we are participating in the next European project. It's DG Prime. 36 partners from all over Europe are working together to form a platform with digital twins, with a demand and supply forecasting system, so that if someone is dismantling a vehicle, he can bring back the parts into the system and he finds someone buying it. And on the other side, someone who wants to produce a sustainable vehicle, he will find components, he will find materials, he will find information about those materials coming from a circular economy. So this is a really cool idea. It's quite complex, but we are very optimistic to form this platform within the next 2 years. And just to close the idea, I said we are very convinced about this detachable joinings and the detachable adhesives. And we want to go next step, and we want to work on with this in the Recreate project. It's also European funded. And here we are doing more and more for reuse of fibers and fiber-based materials and components. And I think you all know that's quite critical, that composites recycling is not that easy, and there's no final solution yet there. And we have a lot of windmills already there. We have so many carbon fiber-based vehicles, boats, and whatever. And that's why we are participating to that. And we want to really improve those processes. So let me give you a very short summary. Reduction, recycling, and reuse are needed to lower the footprints. All of these technologies are needed. If we have a long-term utilization, we can really reduce the ecological impact. Reuse is helpful here. The economic success is not that easy, but there are possible settings and business cases, and we need the fitting regulations to really bring them to the market. And we also need digital solutions to close the value chain. But the good news is that the lower footprints are possible. And that's what I would like to say. If you are really trying, we can, or if you all together try, we can really lower the footprint of every component of every vehicle. And that's what we see in the future. So thank you very much. And if you have questions to me, you can now ask me.